we're going to look at central and inscribed angles. A central angle, by definition, has its vertex here at the center of a circle. So we're going to draw a central angle. And we're going to label this angle CAT. And here's our central angle. That angle is about 45 degrees. Not exact, but pretty close. The relationship to remember in this case is that the arc of this circle, which is arc CT, is the same size as the central angle. So if central angle CAT is equal to 45 degrees, then the arc itself is 45 degrees. So we have that relationship between them. We are also going to look at inscribed angles. Now, inscribed angles are a little bit different. Inscribed angles have their vertex here on the edge of the circle. And I'm going to draw one quickly. And we'll just take it out over here. So we have this angle, angle DOG, and this angle is about 30 degrees. This is an inscribed angle. So angle DOG is 30 degrees. The relationship now to know is that the arc, in this case arc DG, is twice the size of this inscribed angle. So that size would be, that arc would be 60 degrees, or a sixth of the circle. Those are the relationships of the central and the inscribed angles. Now we're going to take a look at a couple of samples just to see how this works out. So with a quick erasure over here, and I will draw in another central angle. And I'll just draw the lines in. If I know that this arc, BC, is 70 degrees, then this central angle would again have the exact same size. It would be 70 degrees. So if arc BC is 70 degrees, then angle BEC is also 70 degrees. So you can see that relationship between them. We're going to run back over to this inscribed angle and make a few changes with it. Draw in another inscribed angle. A little better luck without the meter stick. So if we have this inscribed angle, and we know that this angle is 25 degrees, and I have a central angle here, which has the same endpoints, and we want to know what is the size of this central angle. How would we find that out? Well, we know that this angle, this inscribed angle, is 25 degrees. So let me label my points. C, H, W, and S. So if I know that angle C, W, H is equal to 25 degrees, then I would know that arc CH is equal to 50 degrees, which would then make angle CSH, H, equal to X, which is 50 degrees, the same size as arc CH. So that's how that relationship works. We'll look at one more sample for this video. Erase this quickly. This time we'll have something similar setup to this one. Make it a little easier, make it a little larger. And we're also going to take a look at the angles themselves. That was pretty bad. We'll try one that works. And we'll label these X, Y, Z with W as our center point. Now, if angle, let me replace this and write it down here. If this angle is 100 degrees, and I want to know how large angle L is, we work the same way. We know that arc XY would then be 100 degrees, matching the inscribed angle. So we know that the relationship of XZY, we know that is 1/2 of arc XY. We substitute and finish it up. We know then that angle XZY is equal to 50 degrees. If you have questions, check with the tutors. Get to work.